32, and 39. All of your X values can go in that list. It's very bright. All right, and then in my L2, 57, 38, 255, 408, 497, 25. All right, so I'm just going to write that step up here. So we did stat edit, and we entered our data. So then remember, you have to go to the second y equals and turn your stat plot on. Because we turned them on yesterday, they're probably still on, but you should double check. Second stat plot, yes, this one is already turned on. If not, you just hit enter twice and it'll turn it on for you. So then if you hit zoom stat, which is choice 9, so zoom 9, it should show you your 4 data points. Mine are kind of hard to see, but 1, 2, 3, 4. And then you can figure out if it looks like a line or looks like a quadratic or looks like an exponential. Did everyone get it to show up? If you have another graph on top of it, it's probably because in your y equals menu, someone was graphing another function. So you just want to clear out your y equals menu. That'll get rid of the graphs, like extra graphs. Yeah, you got it. Yeah, see those extra graphs? If you go to y equals and just clear those 2 things out and then hit graph, that way you don't have like the extra. Yeah, you guys got it okay? Did it seem easier today than yesterday? Okay. So now we want to do a regression equation to come up with what that function would be. So that's under calculate. And this time we want to do a linear regression, but you might want to do a quadratic regression or an exponential regression. So you have to be smarter than the calculator because you're telling it. I'm going to stat calculate, and I'm going to choose linear regression right there. And then as long as it should say list 1 and list 2. It's just the sun's reflecting off the snow or something. All right, so when I calculate, what is my function? Y equals, we said we were making $12.75 an hour, right? So my function is actually y equals $12.75 an hour times x. Technically, my y-intercept should be 0. This is just a line of best fit. It wasn't a perfect line of best fit. If I don't work, I don't get paid. So really, this should be plus 0. If I don't work, I'm making $0. And this would round to $0 because 0.00 is $0. So then what does it say for the next part? It says, what does the slope of this equation tell you? What does the y-intercept tell you? What would you make on your paycheck for working 28 hours? And how many hours did a person work? Excuse me. The paycheck was $191.25. See if you can take a minute and answer those questions, A through D. Now that you have an equation, think about what those pieces are telling you. For people who haven't done this in a while, this is called your slope, and this is called your y-intercept for y equals mx plus b. We're going to talk more about that today. So try those on your own for Justin's. Make sure you know how to do them. Oh, I never wrote my regression equation down, but it was what? 1275x plus 0, right? The slope of the equation is what? Your rate, right? Your hourly rate is 1275 per hour. And the y-intercept being 0 just tells you when you work 0 hours, right, you make $0. So it's just your starting position. If you work 0, you make 0. Now maybe you got a sign-on bonus. So for working 0, you still got $50. Then your y-intercept would be $50, and then after that, every time you work an hour, you get the $12.75. So what would you make if you worked 28 hours. Hours we're going to plug in for X up here, right? So we would do 1275 times the 28 hours. And then for part D, you're going to have to use some division, right? They're making $191. You're going to have to divide by their hourly rate to see how many hours they worked. So 1275 times 28. So they made $357. And this one, I'm going to have to take the 191 and divide by my hourly rate. So see if you can finish that question. And we're going to move on to the last part that we haven't done yet, right? We're entering that last set of data. See if we can get it to graph our third set of data. And then it'll be pretty close to that. Lunchtime. How many hours? 191.25 divided by 1275 is how much? 15 hours? So we did okay with that linear problem? So the last one on the back has you graphing the height of the rocket launch. And this has the table going horizontally, but there's your X values and there's your Y values. And you can refer back to part 1 from yesterday if you forget the type of equation. You want to do linear, quadratic, or exponential. So take a look at your scatter plot. See if you can answer those questions too. What was the launch height of the rocket? When does the rocket hit the ground? And what was the height of the rocket 1.3 seconds after launch? We'll talk about those though in a minute. Part C, using your calculator, what was the height of the rocket 1.3 seconds after the launch? So it's hard to do from the graph, but you can go to second calculate and see how their value is choice 1, calculate a value. You can type in whatever X you want to type in. So if you want to calculate the value when X equals 1.3 seconds, all you do is you type in, you go to second calculate value. So at 1.3 seconds, it like zipped up to here on the graph, and it said the height of the rocket was that number, 52.96, 52.96 feet. And we hit the ground after 3 point something seconds, right? We did second calculate 0, and then we went all the way over on the graph. What was it? Was it 3.56? 3 point, what did we say it was when it hit the ground? I forgot to write it down. 3.78. Yeah, 3.78 seconds. All right, so just how to use, a table, a calculator. All right, so just before we move on, can you think of any other real-world examples that could be modeled by a linear equation, an exponential equation, or a quadratic equation? Can you think of any? Like, oh, I know this is exponential. Does anyone know what, like, population growth, if that's exponential, linear, or quadratic? Like, talk about, like, the population of deer in the forest. It usually is exponential. Or how bacteria multiply over time, they double, so then that bacteria doubles and that bacteria doubles. So usually population growth is an example that we'll look at for exponential. Quadratic, I always just think of projectile motion. So the height of, something in the air over time, because gravity works on it and it makes it that parabola shape. Linear is anything that's directly related. So if I wanted to figure out how many shoes there are in the room, I could just take the number of people and multiply by 2. I guess unless you have shoes in your bag for, gym class or something. But, you could take the number of people and multiply by, like, we have 10 fingers on each hand, or 10 fingers on our hand. So you could say the number of fingers would be the number of people times 10. Or if you think about like feet and the number of inches, that's a directly related thing. If you have 3 feet, you have 3 times 12 inches. So linear is anything with, I'm going to say, constant rate of change. But you could write like, how many inches in, you know, in feet or something like that. So we're going to look at lots of examples. Today we're going to look at linear examples, and that's on page 103. So I wanted to kind of guide you through problem number 1, but then I was going to have you and like a partner or someone sitting near you work together and see if you could do example 2 and maybe 3 and maybe we'll get to 4. It just depends on how long it takes to go through these problems, but they're all linear now because our first unit is on linear. So this one is May is growing a bean plant. She forgot to chart the plant's height from the time it germinated, which is when it sprouts out of the seed. But below is the data she collected so far. So it's kind of hard to read where these points are on the graph. So you may want to make it a little darker for yourself so you can see, where the height of the plant is. How can I figure out what the slope of the line is? Slope is rise over the run, right? So what I like to do is I like to pick, one of the points where I'm starting, and I think about what my rise and what my run would be to get to the next point. So what is my rise? Look, it looks like I'm starting at the number 5, and I'm going up to the number 8 on the y-axis, so that would be a rise of 3. And then I'm running from, on the x-axis, 0 to 4. So you don't want to count the boxes. Because if I counted the boxes, this is only 1.5 boxes, and this is 2 boxes. You have to look at the scale at the bottom. So wouldn't the slope be 3/4? I rose 3, and I ran 4. And it says, explain what the slope represents. Slope is always rise over the run. So you can really use these units over here. It's the height of the plant per day. So it's growing at a rate of 3/4 of an inch every day. Does that seem reasonable for a bean plant in the garden? 3/4 of an inch higher each day is what it's growing. So you can take, it's your rise over your run, your y over your x. So it's 3/4 inch growth per day. The plant is growing 3/4 of an inch every day. What's the y-intercept of this line? So I didn't label it up here, but you all know that this is the y-axis and this is the x-axis. So what's my y-intercept? That is the point. What, comma, what? How do I write that as a coordinate? Yep, it's x first, so 0, comma 5. And what does that tell you in relation to this problem? How is the plant already 5? Oh, sorry, this is centimeters. I should write centimeters. I wrote the wrong units. Did any of you catch that? It's the height of the plant in centimeters. So it's only growing 3/4 of a centimeter. Oh, that's pretty small. It's only growing that much, right, every day. What does the y-intercept represent? Go back to the original explanation. She forgot to chart the plant's height from the time it germinated, but below is the data she collected. So what is the y-intercept? When she started measuring the plant, it was already 5 centimeters tall, right? It germinated out of the soil. So when she started measuring, the plant was 5 centimeters tall. Number 3, we're going to kind of review this tomorrow. So this is just kind of seeing like, what do you remember from Algebra 1? Do you remember slope, like y equals mx plus b, like I wrote it up here? So we know the slope and we know the y-intercept. So to write it as an equation, it would be y equals 3/4 x plus 5. I'll zoom in for you. Y equals 3/4 x plus 5. And if you're not quite sure about that today, just ask me for some help, because we're all starting at different places, but it's a linear equation that has a slope of 3/4 and a y-intercept of 5. On what day will the height of the plant be about 17 centimeters tall? I do not want to have to guess and check. I don't want to plug in 4 days and 10 days and 20 days. I want to set my equation equal to 17 and solve for x. So this is why I was going to have you do some practice on solving linear equations if we were remote today, because I need to know how do I solve that for x? Remember how to get things away, like to the other side of the equation? If I'm adding 5, how do I get rid of this 5? Yeah, subtract 5 to the other side. Does that seem like a familiar thing? Subtract 5. I don't have a lot of room here, but now I have 12 equals 3/4 x. How am I going to get x by itself? I'm currently multiplying by 3/4. So you need to divide by 3/4. If you're going to divide on your calculator by 3/4, you either want to use 0.75 or you want to put your 3 divided by 4 in parentheses. So what is 12 divided by 3/4? 12 divided by 3/4. 16, yes. So on day 16, the plant will be 17 centimeters tall. And if you are a farmer or a gardener, sometimes if you start, does any of you start plants inside your house that you germinate them inside and then we transfer them to the gardens in Memorial Day? Does anyone's family do a garden? Yeah, with seedlings and stuff. I was actually thinking we may grow some bean plants in our window in another month and chart their growth, and then I'll transplant them in my garden. You usually need to wait until your plants are so many inches tall before you transplant them into the garden. So this would be a way to figure out, okay, if my plant is growing at this rate, how many weeks until I can transplant my plants? All right, what is the projected height of the plant 45 days based on your equation from number 3? Where am I going to plug the 45 in for? 45 is the number of days, so that's going to go in for x. So calculate what is the height of the plant. It'll be 3/4 times 45 days plus the initial height of 5. So figure out what is the height of the plant after 45 days. Did you type it in? So I got 38.75 centimeters. Do you think that is reasonable? I keep meaning to get a yardstick from next door. So let's see, this is 30 centimeters from here to here. That's 30. We have to go to 38.75, so about. You think that's a reasonable height for a bean plant? I think so. Do you think your answer is reasonable? Why are I not? Sure. Yes, the bean plant could be 38 centimeters. Okay, what about part C? Someone in this class or the other class used the word domain as an important word yesterday when I was talking about, hey, what are the big functions from Algebra 1? Domain is the allowable x values. Do you think this bean plant can grow for 60 days? Could the bean plant grow for 100 days? Could the bean plant grow for 1,000 days? Bean plants die, right, when winter comes. So think about our growing season in New Hampshire. We started inside in March or April, and it grows into maybe September or October, and then it dies with the frost. So this is kind of like your problem solving or estimating. What do you think a reasonable domain would be? The plant cannot grow for a negative amount of days. So all of my day values have to be greater than or equal to 0. I don't know, what do you want to say? How many months? April, May, June, July, August, September, 6. 6 times 30 is what, 180? I don't know, we want to say it's less than 200 days. How long's the growing season for a bean plant? I'd have to look that up. 200 days seems reasonable. Or you could say 250, but it doesn't grow for the whole year, right? That would be 365. So sometimes the growth function is only reasonable for so many days. I can't go backwards and say, negative days the plant is growing. All right, so some of these questions might be too hard, but I'd like you to try with a partner to look at problem 2 and kind of do a similar thing. Can you figure out what the slope of the line is, what the y-intercept is, what it means? Can you answer a couple questions from the graph? On part 3, they're asking you to draw in a line of best fit. All that means is, I can give you guys a ruler, but draw in a line that represents most of the data. And then you're going to answer questions using that line of best fit on number 3. So I'll bring around a ruler, but you can start on problem 2.